Right. Okay, get started. Okay. Let's get started. Yoo-hoo. Um, let's see, one announcement. Some of you may have heard that Java 9 came out last week. You definitely do not want to use Java 9 with Spark. So if you definitely do not want to replace Java with Java 9. There are some, it does break a few things. And we'll start dealing with Spark today. And we'll be spending a fair amount of time on it. One student asked before class, which version of Spark? When you go to the Spark website, it gives you various options. You want the Spark, which is pre-built with Hadoop. The reason for this is Hadoop actually has three major components. One component is the Hadoop file system. Second component is MapReduce. The third component is Yarn, which is a scheduler. Scala, Spark does not come with its own file system. Like, why should we reinvent the wheel? So Spark will run on top of, right, the Hadoop file system. And that's why when you download it, you want the one pre-built for Hadoop. If you don't do that, then you have to download Hadoop, install it, and configure it so that Spark knows how to find the Hadoop file system. Okay? Hey, any questions? What's that? You do not need the IntelliJ IDE. Now, initially, okay. We will be using Scala to write Spark programs. Basically, when you use Scala, when you use Spark, too many S's, right? There's sort of four standard languages that people use. One is Scala, another is Java, and you can use Python and R. Now, it turns out that any JVM language, so like Kotlin, Clojure, Groovy, all those can also do Spark, but so there's a smaller community to start with, and the subset of people in that community want to do Spark is even smaller. Now, the problem is when you're dealing with Spark, as we'll see as we go along, Scala is the first-class language. Java is almost the first-class language, but there's certain things you just can't do, and certain shortcuts you don't get. Once you leave the JVM, you got problems, because now if I use Python, all your Python data that you do in your code has to be converted from the Python process, from the Python format, right, shipped to the Spark process, the JVM process, and converted to, right, the Spark data. And then when we get the answers back, you have to do the same thing, right? Also, the fact that Python is not typed also causes problems, because you're going to standing over you just start flinging code around, right? And what type is this? We don't know. And that could cause problems too. So there's, not only is Python slower than Scala, right? When you're using Python with Spark, you also have a performance hit. Any other questions? So Spark came out of Berkeley. There was this research lab. And there's, right, like they support a program interface with 4 languages, the Nexus shell for Python and Scala. Presumably once Spark runs on top of Java 9, then there'll be a Java interactive shell. And it runs on Linux, Mac, and it's supposed to run on Windows. And there's a number of different things. If we're running this Spark on a cluster, then we need a cluster manager, right? Because Spark needs to know how many machines out there, how to talk to the machines, what they are, etc. And so Spark is written to use different cluster managers. Later this semester, we'll move on to Apache, to AWS, and they've got their own manager they'll talk to. The file system, like I said, Spark can use the Hadoop file system, but it can use other file systems. So when we go to AWS, we'll be using S3. And again, you want a distributed file system. When you take this file, you want it to be partitioned across multiple machines for you, right? That will come later. There are a number of ways of running Spark. To start off with, we're not going to be running on clusters. You can if you want, but again, to start off, you want to understand how to write Spark programs, run them, get them running. And then finally, when you have them running, you might want to move to a cluster. Right? It's just easier to debug and learn in single modes. And there's what they call a pseudo-distributed mode. And when you do that, it does not use a distributed file system because you're running on a single machine, so we don't need it. So use the native file system on that platform. And that's what we'll start doing. And we'll see a demo later on. And again, Python is big in the data science community, but it's not very performant. And there are a number of reasons for that. Now, the Spark people did a lot of work to improve the performance when people use Python, right? So they, Spark does not use the Java data types because they're not performant enough. So the Spark people have their own converters to convert Python data into Spark data and back again. They also went to a lot of work to try and minimize the time that you have to go back between the two processes. Because there is a performance hit. But yeah, the timeline, right? Scala was started like the year before they started Nuts, which became the Hadoop, and so Hadoop really does fall strictly in the object-oriented programming world. Since Spark was started a number of years after functional programming became popular, Spark is heavily influenced by functional programming, right? And that's one of the reasons why we want to use Scala. right? So Spark is relatively new. It came out, version 1 is in 2014. So we're talking about 3 years since the first release. Although people were using Spark before the beta release, golden release, right? Spark has a number of different major components. The Spark Core, which is mainly the initial version of Spark with resilient data set. The Spark SQL, which is now the preferred way of using Spark, and we'll see why as we go along. There's also Spark Streaming, so if you have a continual stream of data you want to analyze, you then use Spark Streaming. And then there's a machine learning library. So we can do machine learning, we can do clustering, we can do deep learning, all kinds of things. We can do it in Spark. And there's GraphX for analyzing graphs, right? If you got network topology, you have like in a social network and you have all these connections and you want to analyze that graph, GraphX provides support for that. Now, Spark is actually a huge project. They did a lot of work. The packages and libraries are on top of Spark Core, large environment, and Spark itself sits inside of what people call the Hadoop environment, and that environment contains lots of other projects, right? It's not just Hadoop and Spark, but there's Hive and Pig and Arrow and all kinds of other things which tie in together for its aspects. So later in the semester, we'll start expanding our view outside of just narrow Spark. And part of the problem is they started with this resilient distributed data set, and then they then added Spark SQL as they went along. And so the documentation is in different stages. So if you start going on Stack Overflow, that's get answers. You'll see a lot of questions and answers about RDDs instead of Spark SQL. That's what having started, right? A lot of books still do it. Even the documentation of Spark, they say, well, first you read about RDDs and then you go and look at SQL, right? And we'll explain this unstructured and structured API, and you'll see these terms over and over again when you look at documentation. The structured API is faster. It's higher level, and it's preferred over the unstructured. And so the basic architecture, you have a Spark driver process or main node or driver, whatever you want to call it, and that runs on a machine, and your code will talk to what they call a Spark session. The Spark session then worries about how many slave or worker machines I've got, and it sends them to me like, you do this, and we'll get the results back. But to do all that, they have to talk to a cluster manager so it knows how many machines are there, what their IP address is, how to talk to them, what their load is, all kind of stuff, right? So when you run Spark on a cluster, we get this basic architecture where the code you write interacts with the Spark session, and it then drives everything, right? When you run it on a local machine, we don't need the cluster manager. But when you run a local machine, if you've got multiple cores, you can have multiple workers. So basically, locally, what you get is your code talks to Spark session, and then you get a bunch of worker threads. And again, if you have multiple cores, those threads can be different cores. And you want to start here. You don't want to start working on a cluster, right? unless you happen to have a cluster in your bedroom, and you're not paying for its use, you're not competing with other people. It's easy to burn up a lot of CPU time if you're running a cluster of 10 machines. You leave the machines running for a while and you forget to turn it off. And the entry point for a Spark program depends upon whether you're doing the unstructured API or the structured API, right? So there's a Spark context, and that is used the unstructured API, right? And it connects to the Spark cluster, knows what the nodes, it manages everything. The Spark context, well, so there's different versions for the Scala version and running in Java. And when you start looking at the documentation, you'll find that it's not just there's a Java version and then Scala connects to it. No, it's all written in Scala, and they then wrote separate versions and classes to do the Java work, which again makes Java not quite the first-class citizen, right? Because you have to work through a different API. The Spark session, right? We use this with Spark SQL or the structured version, and so we're primarily going through the Spark session. It contains the Spark context, right? So the context is still there, still doing the work it does. So these are our entry points into the system, and you'll see in a minute. And you'll see over and over again, Spark has three major distributed structures. One is RDDs, or resilient data sets, distributed data sets. The other are data sets and data frames, right? And all three are distributed across the cluster, and when you do actions on them, transformations on them, they're done on the cluster and then results is back. So it'll parallelize for you. When you have an RDD or a data set or a data frame, right, it's partitioned up for you, right? And each partition runs on a different machine. Right, so you could think of these things as tables, where you take the table and you break it into pieces, and you ship those pieces to different machines, right? So you can do things in parallel. So far, so good. But resilient distributed part's easy, right? It's just a multiple machines. Resilient, there's two ways to make things resilient. One is when you do a bunch of what they call transformations on either an RDD or a data set or a data frame, they're done lazily, right? So that the structure maintains a list of all the operations you want to do on it, and then what you do when they do what they call an action, that's when it says, okay, now it's time to actually perform all these things, right? And so these data structures have a list of all the transformations they're supposed to perform, right? And what that means is if something goes wrong and you have a copy of that RDD or data frame or data set, it's easy to recompute what you need to be done. And typically, the other way as resilient is Spark will, instead of biasing the partitions, it doesn't send a partition to a machine. You'll take this partition and send it to several machines. One is the master and one is the backup. So if something happens on the master machine, you've got that backup, and it has a history of all the transformations that are supposed to be done on that data structure, so it can recompute the results you need. Right? So that's what they mean by resilient. It is fault tolerant in terms of if a machine or cluster dies or somehow goes offline, Spark can recover. Okay, all these, RDDs, data frames, assets are immutable. When you create one, it's done. You don't change it. And also, there's two types of basic actions that we can perform on these data sets. One is called a transformation. That is, you're going to transform it somehow. Oh, you might use map to do something with one of the columns or rows, right? And all these are done lazily. So you say transform, 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 and it doesn't do anything until you actually perform an action. And all actions will then, on it, if you perform an action on one of these data structures, right, that will trigger all the transformations to be done, and the results are going to be then brought back to the master node. Now, there are a couple reasons why they want transformations to be done lazily. One is Spark has a very intelligent scheduler, so it looks at all the transformation to do and optimizes it, right, to see what's the best way of actually doing these transformations. And if you know in advance what you're doing, you can do more optimization than if you do it on the fly, right? And also, if you're transforming a piece of data, you do a map, another map, another map. Do you want to then do those 3 maps on the entire data set, and then do you want to do 3 passes of the data set, or do you want to then combine those 3 maps into a single map and then take each element and do all 3 maps at the same time, that one element, right? To be more efficient. And there's a long list of actions and transformations, right? My first impulse, well, here's a list of all the actions, here's a list of all transformations, but there was, I don't know, like 50 or 60 or 70 actions, and it's like, no, I'm not going to list all 60 or 70. So you get to go to the Spark API, the Spark Scala API, and look at the list, right? Okay. So the number of different ways in which we can run Spark on local machines. The easiest to start with is just the Spark Scala REPL. Now, personally, I'm always surprised when all these people, boast of having a REPL. Like, command line interfaces were, pretty interesting in the 70s and 80s. But after that, I mean, really? Yeah, they have advantages over, compile and run, but, what happens to, you type it in and you make a mistake and you hit the up arrow and then when you're done, what happened to your code? Well, it's all gone. Like, what? And so when we use the Spark Scala REPL, there's 2 built-in variables that they've set up for us. One is SC, which is the Spark context, right? Remember, that's the entry point if you're using RDDs. And then there's Spark, which is the Spark session, right? So they create those for us and we can start using them. right? So when we start up the Spark shell, what I've done is I've installed Spark on my laptop here, and I then put in my path the bin directory for the game was Spark. So I can now just type Spark shell, and I get this big long, introduction. First it talks about log J, so Spark does a lot of logging, so you know what's going on, and we can configure it, but I haven't done that yet. So if it's warning, and you have to get used to the second warning, the native code loader unable to load native Hadoop library for platform. You're going to see this every time you start Spark up. Hadoop comes with, as it says, is a native library, and that pretty much only runs on Linux. So unless you're running Linux and you've downloaded that part of Hadoop, you're going to get that warning. It just means it's going to be a little bit slower, right? It has to use a Java version instead of the native compiled C or C++ version. It's not a problem. The next thing is Spark comes with a web UI, and we'll see that in a minute. And you won't need that initially, but later on it'll be very helpful to tell you what's going on, what jobs were run, what they did, how long they took, things like that. And then once you get that, you'll get a prompt, right? So if we go here, can everyone read that? And it's a little small. Let me. So I just type Spark, right? And what it's doing now is it's spinning up Spark in all its glory. It takes a while to get the warnings. It can't bind to port 4040 because I'm running another version of Spark already, which is using port 4040 for the UI. And then we get the standard scale of prompts, and we could do we can now start typing scale of code, right? And we can type in arbitrary scale of code we want, right? And we can now also type in Spark code. Okay, when I type FC, it doesn't generate a new Spark context. There's a global variable defined for us, FC, which is a Spark context. So the question is, what is a Spark context? Let me modify the question and say, what do we use it for? The Spark context, remember, there's a Spark context and a Spark session. We have to keep, there's going to be a lot of terminology we have to keep straight. Session and context, right? The context we use to create RDD. And so if we want to, we can, it's going to be fun. I can say parallelize and one. Right, so parallelize basically takes that collection you give it and converts it into RDD. So you'll see this a lot in examples because it's self-contained. But normally, we'll read the data from the file because we're interested in larger data sets. So what I did here is just parallelize, created a RDD. Yes, RDD is a specialized data set that Spark runs on. Right? Remember, there's 3 different types of specialized data. There's RDDs, there's data sets, and data frames. Again, another dichotomy we have to worry about. RDDs, we can think of as, well, it's a collection of data. Right? It's a collection of data. The question is, how does it write like lists, etc. The thing to know about Spark is they no longer use the Java or the Scala-based types, right? The reason is those types are too inefficient, right? And so they have their own data types, and Spark deals with memory itself. Again, because it's faster. The general reports was that going from using Java types to their own types and optimizing them for their Spark usage, they saw a performance increase of a factor of 17. So it's not like 20% faster, it's like 17 times faster. And so one of the things we get to do is we get to study what operations we can do in RDDs and data sets and data frames. Now, most of the operations on RDDs and data sets and data frames are the same. And part of the reason is, right, when you create a data frame or data set, Spark behind the scenes actually represents as an RDD, but it has more information about the structure. And so when you perform an operation on a data set or data frame, it's actually eventually is done at a low level in RDD. And we'll see as we go along what type of operations we can do. So now we can yeah, it doesn't know about explain, but I should be able to count. And how about that, right? Yeah, it doesn't know. Right, so this is the Spark. Right, Spark shell. So that's one way we can actually run Spark. Another way we can run Spark is we can actually write a program. Yeah. Does this work? No. Why does it? We can actually write a program, and we can compile it, and then execute. If we're doing a standalone mode, we can have it so it starts up a version of Spark, runs it, and stops, right? When we actually want to go to a cluster, what you can do is you can compile it, create a jar file, you upload the jar file, and run it on the cluster. And you have to do things like, okay, create an object, and then create a main, and then we have to create our own either Spark context or session, we have to configure it, and then we can start doing things, right? Let's see, where is it? Yes. A third way in which we can run Spark locally is through a Jupyter Notebook. Now, to do it, there are 3 different kernels that run Spark. One is, the one I'm using is the Apache Toree, and that's Toree, and I'll put a link on the website later. And it has instructions on how to install it and then how to run it, right? And part of the installation is it doesn't install Spark. It assumes you have a local Spark installation on your machine. And then, it creates a global variable SC for Spark context, right? And so we can run it and do things like that, right? It does not define a global for Spark session, and so we have to create our own, right? I did that here. Yeah, these examples also are in the slides coming up, but I can make this notebook available. And now we can start doing various things. This example will go through coming slides, but I have a file data, and it's a JSON format, so I want to read it. So spark.read. And again, right, the Spark context, the Spark session are your entry points, and you're creating these distributed data sets, right? If you already are, you need a Spark context. If you want a data set or a data frame, we need a Spark session. And we don't just say read the file, it's Spark read, and then we tell it, is it JSON or is it, what the format is, and then, we give it a path, and then it's going to actually read it and create in this case, it's going to create a data frame. And again, it can take a while to get used to data frames and data sets and RDDs, right? Right, so here we are, I'm reading the file. Now, at this point, right, when I say val equals blah, 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 it has not read the file. It's done lazily. It's not going to read the file until you perform an action, and that action then requires it to actually read the file. Right, so when I say take 2, it gives me, look, it's an array, it gives me, look, here it is, there's and let's see, what else do I have here? Explain. So what happens is, on these data sets, again, RDDs, right? Spark is going to try and optimize their performance. So it doesn't do any transformations on it until you actually ask it, right? And so each data set or data frame has what they call a plan. This is all the operations that we need to do on it. And we can see those operations when you ask for explain. Plan explain just gives you the physical plan. And when you explain true, it gives you more detailed. It gives you there's a logical plan and a physical plan. All right, so it goes through several steps, all right, to come up with this plan, and you get to see what it's doing. And then we can see all kinds of, I can sort it, and then say, give me the, and so what this data is, it's a summary of flight information coming to or from the United States and other countries, right? And so the format, and we'll see in a minute, there's a destination country, origin country, and then how many flights, regular scheduled flights come and go from those countries. And if you want to see more, we can provide okay, now here is an important thing you have to remember. You're going to forget, and you're not going to understand it for a while, right? Everything is done lazily. What does that mean? It doesn't read until it needs it. It needs it when I do what they call an action, but it doesn't cache the result. It does not cache the result. So here, yeah, so here's a problem, right? So what I've done is, I read the file, but it's not read yet. It's done lazily. When I say take two, take is an action, so it's going to perform those actions, right? But now I'm asking it to explain. Well, that's okay because it's just giving it the physical plan, which it keeps it around. Now, sort is another transformation. It's not an action. Now, when I say show, oh, okay. Now you perform the read and the sort. So, right, sort is a transformation. Transformation is done lazily. So when I say sort, when sorted flight data is now a new data set, or data frame, but it's not evaluated, right? So now if they show on it, what happens? No. It executes the read and the sort and the show. No. There's a reason for it. And the reason is, look, I have a small file here, right? But you have a large file, and if every time you did a transformation on something, and you kept a separate copy of that, it's going to start consuming lots and lots of memory, right? And so this is an important way Spark operates is transformations are all done lazily, and every time you do an action, right, it then performs all those transformations, including reading the file. Now, there are ways of saying, look, okay, here's a transformation, now save this version, so I'm going to use this over and over again, right? But the default is not to do that. The default is just to, every time you do an action, you perform all the transformations that accumulated on that data set or data frame. Any other questions? That's right. The comment was, these lazy rules allow you to do a bunch of transformations, map, filter, group by, blah, 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 right? And not worry about how efficient it's going to be. Because Spark, it's going to look at this and say, oh, they're doing this and this, and it's going to rearrange things to be as efficient as possible, right? When we're dealing with data sets and data frames, Spark converts all your transformations into abstract syntax trees, right? And then it has all these trees, and it starts, how can I rearrange this to be more and more efficient, right? So yeah, you don't have to worry so much about which order to do things and which is more efficient or not. Any other questions? The question is, why don't they cache all of these every time they do an action? That file is 5K, 10K. What if that file is 10 gigabytes? And you got this huge thing in memory, and now you're going to cache that 3 times? You're going to run out of memory real fast, right? The whole point of Spark is run large data sets in memory, right? So that's why the default is when you perform an action, right, the results are pulled back into, right, the master, and that's where you get the data. But the worker nodes don't keep a copy of what they just did. Unless you tell explicitly, I want to cache that particular result, that particular data set. I want to cache it because compute it and save it because I'm going to use that one multiple times. So far, so good. Spark SQL is called that because you can actually use SQL. And you have basically, we can write out the SQL by, standard, just a string and select star from blah, 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 and where blah, 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 or we can do it in Scala. And there's no performance penalty for doing it either way because they're both optimized for the same engine behind the scenes. So the question is, does this Spark lock the file? I don't know. Well, if it's your data file, you typically don't want to change your data files. No, they're files, regular files, right? And your file system allows you to change files, right? And Hadoop, Hadoop file system does not allow you to change files. S3 does allow you to change files. Other questions before we go on? The question is, will we run this in AWS? The answer is yes. Right? You have to run something in AWS. Right? If for no other reason you want to put it on your resume, I use AWS, right? And actually, it's once you've done the process 1 or 2 times, it's like easy. You get your program running, you compile it to a jar file, you upload the jar file to AWS, you upload your data to AWS, put in S3, and then there's a GUI environment that you tell, okay, I want this type of cluster, these type of machines, this many machines, and then run. And then you wait. The good news is that up until about a month ago, actually a couple weeks ago, when you ran a job on AWS, they charged by an hour. So if you ran it for 5 minutes, they charge you for an hour. They've changed that now. They charge by the second, because Google charges by the minute. Well, it does add up, because if you run on 10 machines and you run it for 5 minutes, that's 10 machine hours. You're paying for each machine, right? And now you're paying for 10 machine 5 minutes. Oh, yes. I'm like, come on, they went from an hour. I mean, right. Last year I'd queue up things I wanted to run and then start and make run, and keep track of where my hour boundary is. And okay, I'll stop now because I went through 55 minutes. I'll stop now. So but if you don't stop it, I mean, they'll keep billing you. Yes, again, there's, explain. So it's explaining, and what you're seeing happen is now there's actually 2 transformations done. One is the reading and one's the sorting, and so you get 2 different. And then we can do all kinds of the standard sort of SQL like things. I can group by destination country name. Again, group by is a transformation, and so it's done lazily. And then what I'm doing now is I'm asked to compute the mean on the count column and then show it, and we then read the file and we sort it, and then we do actions over again. Okay. Let's go back to, where are we? The slides. Some sample interaction. Again, is just doing some silly things. I do Spark range. I get, numbers 1 through 100. And what I get back is a data set. And we'll talk about the differences, and we'll see if we get to it today. I can then convert it to a data frame by giving the column a name, right? And now I get a data frame back, and now I can start doing things like, give me all the numbers that are divisible by 2, right? And then I can call count on, and count as an action, and that's going to then perform all the transformations and bring the result back to. And this does more than you think, because if the data is in different machines, right, it's not bringing the answer back from one machine, it's bringing the answer from all machines, and then combining the answer to get, right. That's a very good question. And the question is, I want to have a big data set, I'm going to sort it, what happens, right? The problem is, of course, if I sort it, say I've got 3 machines, right? So I divide my data set into 3 pieces, A, B, and C. If I sort A and I sort B and I sort C, it's not sorted yet, right? Because there's some, if there are names, there'll be some A's here and some A's here and A's there, right? So what we need to do is we need to sort the whole thing. And this we'll get to study in more detail. It's called the shuffle. So what Spark and Hadoop both do is when sorting is a good example is, okay, we'll sort in all machines, right? But then what they're going to do is say, okay, I want the first, say I'm just sorting strings, right? So it's A through Z. I'm going to divide, Spark can estimate, okay, I'll put the first third of the alphabet letters on this machine, next third on this machine, that machine, right? So it has to then shuffle the data. So all of these on this machine have to be sent over here, right? Right. And it's called a shuffle because everyone gets involved and they're all sending data to each other, right? And that, of course, is expensive, right? Because you're now having to send data across the network, which is a lot slower than doing computation or even writing to disk, right? And so you really need to be aware of which types of transformations or actions will generate a shuffle. Now in Hadoop, right, Hadoop only has two things. It does map and it does reduce, right? And Hadoop, right, every map is always followed by a shuffle. Okay, so we've got some simple stuff, right? So here's an example. It comes from the Scala Spark documentation online, and which reminds me that I updated reading list. So there's 3 documents of the Spark site you want to read. One is the quick start, always a good place to start, and then there's a documentation that talks about RDDs, and then the other one talks about SQL, Spark session, etc. So it's a simple example that comes from them, and basically it says, look, here's the path to this README file, and then again Spark read, right? And then it's a text file, right? And it creates a data set. And again, this is lazy. We haven't read the file yet. I'm going to do count. Now we'll read the file and recount it, right? And if we're on multiple machines, each machine would then read their piece of the file, and then they would do their count, and the count would be sent to the master, and they would update. You give me the first thing in the file, write a filter, right? There we have a sort of standard filter in Scala. So, and again, filter is a transformation, so it's done lazily. And so when I do this count again, we're reading the file, right? And then applying the filter and then counting results. Any other questions? Spark reads, knows about various data types. Now we type it wrong. Comma separated, right? Format. JDBC, JSON, text, and a couple other. When we start up Spark, we can tell how many workers we want. So if we're doing the Spark shell, we can basically tell how many. When we configure an application, a Spark application, there's usually a configuration file, and that configuration file will specify how many workers we want. When you go AWS, that's part of the configuration of your job. You tell how many machines you want to use. Now, if you want to run an application, we can use SVT to actually compile for us. And this is the SVT file that the Spark website gives. Unfortunately, when I tried it, it gave me a not a conflict, but a missing dependency. Either missing dependency or a conflict in dependencies. So I haven't figured that out yet. So what I do when I compile IntelliJ, I just manually include all the Spark jar files. And it works fine, but I haven't figured out why. I don't know if my SVT is broken or there's a dependency problem. Yeah, Talent is the most recent version because some people may want to use Spark 2 or Spark 1.6, right? So it's telling SVT which version to download. Probably. Don't know. When I tried it with 1.6, it worked fine. Oh, I don't know. Huh? And then here's a sample program using RDDs. Again, we need to create a Spark context. We have to configure it. So I gave it a name and then set the master. And when I read a text file, I can specify a minimum partitions to use, and then I can do some filters, and then do some work.
So my question
Mm-hmm. No, if you set 4, then it's going to use all 4 cores, right? If you set 8, then each core is going to be given act as 2. And so if you only have 4 cores, it doesn't make too much sense to ask for 26 workers, right? Because you'll overload each core. And using the Spark SQL, again, it's, we need an object, get a main, we need a Spark configuration to configure it, and then we need to build a Spark session, which is done differently, of course, just because keep you on your toes. Here I just read a file and count them. And now when I run this program, you get lots of output. Lots and lots of output. And so the problem becomes when you start doing prints, they're lost in the output. It's actually 3 or 4 pages of output. And the program wasn't doing much, right? It's giving you all the log statements from Spark. And so most of this for now is gibberish, right? I mean, But eventually, when you become a Spark expert, you'll be able to read this and figure out what's going on and help you debug it. Right. I forgot to show you one thing. So let me go back to when I'm running Spark. It actually also starts up a web page for you that tells you. So here is the website for these for this Spark notebook that's running, and it tells us, the various jobs. So I've done 8 jobs. When I'm submitted, doesn't take very long, right? How many stages, right? We can start, going down. It shows you the stages and all the various things it did. We can also go to stages, look at the stages, right? And get, information about the job, successful or not, how much coverage collection time, et cetera, et cetera. And again, initially, this is going to be overkill, right? It's too much information, but you know about it. Any questions? Hopefully by the end of the week. It'll be on Spark, right? So if you haven't installed Spark, now's the time. Make sure it works. What's that? Later. Spark is a big system, and it's going to take us a couple of weeks to sort of get over the shock of looking at the big system, all the terminology and what you can do and not do. So you don't want AWS is not free. Now you can get $100 credit on AWS, but when you're running 3 or 4 machines at a time, it's that. You have to find a cluster manager and install it. And some people did that last year. I mean, they actually had several machines at home. They did all assignments on the cluster. Does Spark support GPU acceleration? No. I think I will end here today. I'm give an exam in the next class. I need to get over there to get them organized. Make sure you install Spark. Make sure it runs. You've got reading assignments, and hopefully by the end of the week you'll have something to keep you busy this weekend.